say linear, what does that mean?
Not parallel, it's just a straight line on the graph.
Yeah, just a straight line on the graph. What does the equation of a line look like? So linear function y equals mx plus b, or if it were written in function notation, we talked yesterday about how f of x replaces the y, so you might see f of x equals mx plus b. Those are both examples of linear functions. What does m represent? And what is b? Remember, y-intercept, that means where the graph touches the y-axis. Alright, so first we're just going to practice graphing a few lines, making sure you remember that, and talking about domains and ranges of those. So our first one, I want to graph f of x equals negative 3x plus 7. We're also all grown up now, so I don't print graph paper for you. You have to draw your own graphs. So when I graph this, where do I start? From our origin, 0, 0, our y-intercept is 7, so we go up 7. So we hit our y-axis at 7. Slope is negative 3. What does that mean? You can think of it as negative 3 over 1. So you go from your y-intercept down 3 and right 1. Or the alternative, you could go up 3 and backwards 1. Won't matter. You really only need 2 points. You can do more if you want. Keep continuing your slope. I don't draw straight lines very well up here. So then we draw our line. What is our domain and range? Infinity to infinity. This is going forever in the left and forever to the right. Our range. Same thing. We have one end going down, one end going up. I want you guys to try one. So graph it, give me the domain and range. So where do we start? Y-intercept of 3, that's always on the y-axis. Slope is 2, so up 2, right 1, or you could go down 2 and left 1. And then make your line. Domain and range? All right. What if I give you this one? So x equals negative 3. Straight line. So if it's x equals, that is a vertical line, so up and down. It's hitting our x-axis at negative 3. Domain and range are a little bit different here. What's my domain?
-33.
We only hit that one value, right? So if you did an interval, your starting and stopping point is the same. Usually if it's just a single value, we'll just go back and write it as a solution set. So my domain is just the single value negative thing. Our range though, we still have one end going up forever and one going down forever. So that would be negative infinity to infinity. I want you guys to graph f of x equals 4 and gives a domain and range. So f of x is the same thing as y equals 4. There's a horizontal line at 4. My domain this time is going forever to the left and right, so domain negative infinity to infinity, but range we are only hitting a single value, so my range is just 4. So every line has a domain and range of negative infinity to infinity except horizontal and vertical lines. Vertical line just has a single domain value, horizontal line just has a single range value. Right, do we remember the graphs and that okay? How do we find slope of a line? I mean, we were just doing slope when we graphed some of these. We said the slope is 2. How did we graph that?
Go up to.
So rise over run. If we have 2 points, 2 order pairs, then remember you had to do y2 minus y1 over x2 minus x1. So we need to remember that. Slope is telling us how steep our line is. It can be positive or negative. If our line is increasing, that's a positive. If it's decreasing, that is a negative. If we're looking at a graph, we can count it as rise over run. Otherwise, we have to do the y2 minus y1 over x2 minus x1. So positive slope means increasing, negative slope means decreasing. What does it look like if a line has 0 slope? What kind of line has 0 slope? Straight across, horizontal line. In that case, it's not increasing or decreasing. Do you guys remember what we call that? If it's always the same? It's a 0, and we might also say constant. Okay, so a 0 slope is sometimes called a constant function. It's always the same. So you need to know those increasing, decreasing, constant terms. So we just said a horizontal line has a 0 slope. What's the slope of a vertical line? Undefined. So that is the next thing we need to make sure we remember. So if you remember it, great. If you don't, you want to make sure you jot it down. Slope of a vertical line is undefined. If you do rise over run, you get something divided by 0, and we can't do horizontal line has a slope of 0. If you do rise over run, you get 0 divided by a number, which is 0. Everybody have what they need from these slides? So let's practice finding slope from two ordered pairs. So if we're looking at these ordered pairs, remember there's x of the first is our x1, y of the first is y1, x of the second is x2, y of the second is y2. So the formula we wrote down, slope is y2 minus y1 over x2 minus x1. So we're just plugging into that. Would it matter if you call this first order pair x2, y2 and the second one x1, y1? No, as long as you didn't flip the x's and y's when you set up your slope formula. So negative 6 minus 4 is negative 10 over 4. Typically we like to keep our slope as a fraction because when you're graphing it's a lot easier to do rise over run if you're looking at a fraction instead of a decimal. But we do want it in lowest terms. So negative 5/2. Alright, you guys do B. x1, y1, x2, y2. So y2 minus y1, x2 minus x1. 8 minus 8 is 0. 5 plus 3 is 8, but 0 divided by 8 is 0. What kind of line is this? Yeah, a constant, a horizontal line. If you are looking at a line, does it matter which 2 points you pick to find your slope? No, the slope is the same everywhere on the line, so any 2 points on that line will give you the same slope. All right. So that's this one. When we're graphing lines, okay, we can have the equation, but we can also just have a point and a slope. That's really all you need to graph it. If I give you the point and the slope, where do you begin your graph? And then my slope is 4/3, so we would go up 4, right 3. Or down 4 and left 3. So as long as you have 1 point and the slope, you can draw your graph. You guys do one. So sketch me the graph meeting these requirements. slope is -2/3, so you can go down 2 and right 3, or up 2 and backwards 3. We know it's a decreasing line because of the negative slope. So it should look like this. Are you guys remembering all of this? Good. All right, any questions so far? All right. Take a second, match each of these lines to its graph. I'm actually seeing quite a few different answers as we walk around. So let's kind of start the first one. If I look at this, my slope is a +2. So what does that tell me about my line? It's increasing, right? Positive slope. We hit the y-axis at +3. Only one of these lines is increasing. Which one is that? C. So we can see it hits a +3 up 2/1. Okay, both 2 and 3 have a negative slope. So that means those lines are decreasing. So A and B. This one has a y-intercept of +3. Which one has a positive y-intercept? A. So 2 is A. This one has a y-intercept of -3. So that's B. Okay, so make sure you're watching the increasing, decreasing, and where your intercepts hit. Let's talk a little bit more about x and y intercepts. What do I mean by that? What is an x-intercept?
Where it crosses the X point.
Yes. The graph crosses the x-axis. If you are on the x-axis, so every single point on the x-axis has something in common. What's the y value of all those points? 0. So to find x-intercept, your y is 0. A y-intercept is same thing but with the y-axis. So where the graph crosses the y-axis. And if you are on your y-axis, what's true? What's 0? The x, yeah. Every point on the y-axis has an x value of 0 if we're talking about those ordered pairs. Alright, so let's practice finding x and y intercepts. We will do this a lot throughout the year, not just with lines, with all the different functions we need. But it's the same idea every time. If you are on the x-axis, your y value is 0. So our calculation, all we have to do is plug in a 0 for the y, and we can solve it. So 3x equals -8. Divide. It doesn't work out nicely, so let's just keep it as a fraction, 8/3. I did say I wanted it as an ordered pair, so what would that ordered pair be? Mm-hmm. So for a y-intercept, if you're going to hit the y-axis, your x is 0. And our y is -2. If I write that one as an ordered pair, that would be? It seems like I always have people make mistakes on the ordered pairs. They want to write these together as one point, and that is not the case. They're 2 separate points. 1 point on the x-axis, 1 point on the y-axis. So you guys do one. X and y intercept. y-intercept, if you're on the y-axis, then your x is 0. So 6y equals 18. Divide. And we get -3. So the x is 0. Y is 8. Okay, looks like we're doing okay with this. Any questions there? Couple more problems and I'm done for today. In 2006, about 60 billion text messages were sent in the United States. During the next 6 years, text messaging increased on average by 407 billion messages per year. Part A, find values for M and B so that y equals mx plus b models the number of text messages sent in billions x years after 2006. So we're trying to write an equation of the line. The important thing here is understanding what your variables stand for. In this case, my x is my years after 2006. What does the y represent? The number of texts, really, that were sent. Okay, so we need to know our slope and our y-intercept. Y-intercept is like your starting value. Because we are basing this off 2006. That's like when my x is 0. 2006 is 0 years after 2006. How many were sent in 2006? 60 billion. So my y-intercept, my starting value, is my 60. I don't have to write billion because it already told us that y is being measured in billions here. Your slope is telling you how it's changing. What is the change in this? It's increasing, so is the slope positive or negative? By how many? So my slope is positive 407. Right? Think of it as your y-intercept is like your one-time thing. It's where we started. Okay? The slope is what happens every year. Every year it was going up 407. So we could use our equation to estimate the number of texts sent in 2012. X is the years after 2006. So 2012, X would be what? 6. That's 6 years after 2006. So we just plug a 6 into our equation. And what do we get? And what's my label on that? Y is in billions. Any questions there? I'm going to stop here for today. Tomorrow we're going to do a little activity together at the beginning. I have just a couple more examples, and you will have some work time. I might also start the next section tomorrow, depending on how it's going. But I want to give you some time. There's a Math Excel assignment open. It's the same one for today and tomorrow, so you don't have to have it all done. You'll have some class time to work tomorrow as well.